Okay, let's dive into this. You know how your phone in like a split second can pull up every single picture you've ever taken of your dog or find a specific friend from thousands of photos? It feels kind of like magic, right? Well, it's not magic, but it's a totally fascinating process of teaching a machine how to actually see the world. So let's start with a really simple question. Take a look at this picture. How on earth does a machine know that this is a furry, four-legged creature of chaos, also known as a cat, and not a dog? Or, for that matter, a pepperoni pizza? That's the big mystery we're going to solve today.
To get to the solution, first we have to really understand the problem. And the problem isn't the cat, it's the pixels. See, to a computer, a picture isn't a picture at all. It's just a giant grid of tiny colored dots. And that makes seeing something simple, way, way harder than you'd think.
And this slide right here really drives that home. Your brain is a pattern matching superstar. It sees whiskers, pointy ears, fur, and boom, your brain just goes, yep, that's a cat. But an old school computer? Oh man, it just sees a giant boring spreadsheet of numbers. It would have to check every single pixel one by one just to get started. It's slow, it's clumsy, and honestly, it's just not very smart.
So, how did we get from that clunky spreadsheet to the absolute genius living in your phone? Well, the huge breakthrough was to stop thinking like a calculator and start thinking like a brain. Scientists created a system inspired by our very own visual cortex, and they gave it a super nerdy name, the Convolutional Neural Network, or CNN for short. And this, right here, is the hero of our story.
So let's see how this thing actually works. I want you to think of a CNN as an AI detective. It doesn't just stare at the whole crime scene at once. Nope. Instead, it uses a special kit of tools, which are called layers, to find clues piece by piece, building up the case from the ground up. The first tools out of the bag are the edge detectives, or in technical terms, the convolution layers. Just imagine a whole team of tiny investigators, and each one has their own specialized magnifying glass, and they're all scanning the photo. One detective is only looking for horizontal lines. Hey, whiskers. Another one is only looking for vertical lines. Ooh, the edge of an ear. They're just finding the most basic, fundamental clues first. Okay, so after that first pass investigation, the AI basically hits the zoom out button. This is the pooling layer. It takes all those little clues that the edge detectives found, and it summarizes them, keeping only the most important signals. It's starting to see how all those little lines and curves might be forming bigger shapes, like an eye or a nose. It's kind of like looking at a city map instead of every single street sign. And finally, we get to the grand finale, the final verdict. This is where all the evidence, the lines, the shapes, the textures, it's all grow together into the main office. The network, our chief detective, looks at everything its team has found, from simple edges to complex shapes like pointy ears and fluffy tail, and it weighs all that evidence to make the final call. And what is that decision? Well, it's not a simple yes or no, it's a probability. The AI says, okay, based on all the evidence, I'm about 90% sure this is a cat. I'm 8% sure it could be a dog, and hey, you never know, there's a 2% chance it's a pizza. It's not about being 100% certain. It's all about making the most educated guess possible. So, how does our AI detective get so darn good at its job? It wasn't born a genius, that's for sure. It has to learn. And the way it learns is by making mistakes. Lots and lots of mistakes. Millions of them. It all happens in this simple but relentless four-step loop. First, it takes a guess. Then it checks the right answer. If it was wrong, oops, it called a cat a dog, it zips backward through its own brain to figure out exactly which clue led it astray. And finally, it makes a tiny, tiny adjustment to its detectives so it won't make that exact same mistake again. And then it does it again and again and again. And this number right here is key. We're not talking about doing this loop a few hundred times. This process is repeated millions, sometimes billions of times, using these massive libraries of photos that humans have already labeled. This is a cat, this is a dog, this is a pizza. It is just pure, relentless, brute force practice. And you know what? After seeing a million cats, our AI detective gets scary good at its job. And here's a fun fact that might blow your mind. This idea isn't new at all. CNNs were actually pioneered way back in the 1980s, but computers were just way too slow to run that learning loop millions of times. The game changer came in the 2010s, from a place you might not expect, video games. The powerful graphics cards, the GPUs that were designed to render amazing game worlds, Well, they were also perfect for running thousands of these calculations all at once. They provided the muscle to train these networks on a massive scale, pushing accuracy to over 99%. Look, this is all really fun when we're talking about cat pictures, but why does this technology truly matter? Because the exact same logic that finds a cat in your photo library can be used for so much more.
This right here, this is the real magic trick. The superpower isn't just seeing, it's generalization. See, the AI isn't just memorizing a million cat photos. It's learning the abstract idea of what makes a cat, the essence of catness. The pointy ears, the whiskers, the fur, that specific shape. And once it learns that skill, you can apply it to almost anything.
And we're seeing this power everywhere. Self-driving cars use it to spot pedestrians. Doctors use it to analyze medical scans and find tumors with, frankly, superhuman accuracy. But, and this is a really big but, there's a crucial catch. The AI is only as good as the library you train it on. If you only show it pictures of fluffy orange tabby cats, it's going to get really confused by a sleek, hairless Sphinx cat. It doesn't know cat, it just knows the patterns you've shown it. Garbage in, garbage out, as they say.
So we've unraveled how an AI learns to see. But that leads me to one last thought. What about other kinds of AI? You know, the kind that learns to understand language, to reason, and, well, to talk to you right now. That, my friends, is a story for another time.